Alright, this is my second video on graphing rational functions. If you're not familiar with the basics, you need to watch Graphing Rational Functions 1. That'll talk about asymptotes, domain, and range, and kind of the basics behind how those works, the basic look of the graph, and all those different pieces. So we're going to start adding a few more pieces to our rational functions. So we started with in that first video y equals 1 divided by x. Obviously on this first example, we're adding a little bit more. Now, how this is all going to work is it's all based on transformations. We kind of talked about A in the first video and talked about the stretch and the reflection that it can cause. So that constant up top can reflect, can stretch things. Now we're going to add in two more pieces in this video, and we're actually going to deal with H and K. So it's good as a quick reminder, H is going to slide things left and right, and K is going to slide things up and down. So looking at that will help us kind of approach these problems a little bit easier if you're fresh on your transformations in that approach. So this first problem, y equals 2 divided by x plus 3. So I always try and look at things from a transformation point, and we always talk about that center point that our graph focuses around. So the center point on a basic y equals 1 divided by x graph is usually in the center. It always starts at 0, 0, and we're going to talk about with the transformations how things moved. Well, I have two numbers here. I have this 2, which, remember that's a, so we're going to have a stretch there. But I have this plus 3, and we need to talk about how is that going to affect my graph. Well, that plus 3, that is in the k position. That's on the very, very end, so that is going to slide everything up 3. So originally we were at 0, 0 for my center, but because of that plus 3, everything's got to slide up 3. So I go 1, 2, 3. This is my new center. Now, it doesn't have a really mathematical point, but it is going to drive how we graph a lot of this. So that plus 3 is going to slide everything up. There's my new center. And remember in the last video how we had those kind of crosshairs, which is also going to be our asymptotes, go right through that center point. So what I just drew in a highlighter is my two asymptotes. So to come up with the asymptotes, we're going to have x equals and y equals. The best way to come up with those asymptotes is just use the coordinates of that center point. So the coordinates here are 0, 3, so x is 0 in that case, y is 3. So those are my asymptotes. I have an asymptote, a vertical asymptote of x equals 0, that is that vertical line, and I have a horizontal asymptote at y equals 3. I'll hold off on the domain and range. I'm going to graph this. One more thing I have to consider. So I took care of that plus 3. That slid everything up. This 2 here, I have to remember, is this going to reflect it? What is it going to do? That 2 is going to stretch things. So that's going to pull this graph a little bit away from the center. No reflection here because there's no negative. So I'm going to pull things a little bit from that center. So my graph's going to come down. Again, we do not cross our asymptotes with these rational functions. So there's one leg. My other leg, again, I need to have that stretch pulled a little bit away from the center because of a stretch of 2. If the stretch gets bigger, if this was 20, then I'll be really pulled away from that center. But a stretch of 2 is just going to pull things a little bit away. So I have my graph. So I need to go in and talk about my domain and range. And remember from the last video, the domain is all x values. So I'm allowed all these x values except, that asymptote caused a problem. I could use 10, -5, but that yellow highlighted asymptote says, hey, we cannot use x equals 0. So we're going to have all real numbers except, and remember how I talked about in the last video, the domain and range kind of follow the asymptotes. We're going to have all real numbers except x cannot be, 0. For my range, we can look at, what y values are allowed. So I'm okay, but except this right here, that's an issue, and I keep going down. So we're going to have all real numbers except y can't equal, follow the asymptote. Y cannot be 3. And again, the reasoning behind that is our graph never crosses those asymptotes. We're not allowed to use x equals 0 or y equals 3. So that is our first graph. Moving on to our second one. I have y equals 1 divided by x minus 2. So I need to start and figure out where's my center. So remember, my center first starts at 0, 0. I need to look at what transformations are happening here. Well, I have this x minus 2 here in the denominator. So what I'm dealing with there is h. But the thing with h, we know it slides things left and right, but even though it says minus 2, which don't get tricked and think, all right, I'm going to move everything to the left 2. H is kind of the opposite there. It's actually going to slide to the right 2. So my center slides to the right 2. It's at that point. So there's no other transformation there. I have just a 1 up there, no k. So nothing else going on. I'm going to draw my asymptotes with my highlighter here. So that's going to go through that center point. And since there's no reflection, no stretching, my graph is going to come down. It's going to keep pretty close to that center point I drew. So we're still going to stay pretty close, and this is kind of a rough sketch, and that's fine. Very, very close to that center point because there's no stretching going on here. So it's hard to tell, but my graph is there. Goes up and follows that. Follows up here. So my asymptote's there. Just name the coordinates of that center point. So the x value is 2, and my y value is 0. So my vertical asymptote, x equals 2. My horizontal asymptote, y equals 0. So when I go and do my domain, it's going to be all real numbers except x cannot be 2. For my range, we're going to have all real numbers except y cannot be 0. So notice how domain and range kind of follow your x and y there. So there's my graph. One last one, and this is going to be the most complex one I'm going to have on my third example. I have y equals negative 3 divided by x plus 1 minus 3. So there's a lot of transformations going on here. So what I'm going to do is try and keep all that in mind. I'm going to first start with the center and figure out, am I shifting left, right, up, down? What am I doing? So I got this x plus 1 and a minus 3 on the back, and I'll get back to that negative 3. So this x plus 1, that is actually going to shift everything to the left 1. So I move my center to the left 1, and I'm going to just leave my pen there. I'm not going to draw yet. That minus 3 is going to shift everything down 3. So I go to 1, 2, 3. That is my new center point. So everything shifted left 1 and down 3. Left 1, down 3. My asymptotes, since we're dealing with a rational function, are going to center and go through that point. So there's my horizontal. I'm now drawing my vertical asymptote. So to say the coordinates, my vertical asymptote is going to be x equals negative 1. My horizontal is going to be y equals 3. Asymptote x equals negative 1, horizontal y equals 3. So I'm going to get back to graphing this. So I took care of the plus 1 and the minus 3. I now have to deal with this negative 3. So there's kind of two things that I'm focusing at. One thing is I got that negative sign. So instead of things being in the bottom left and top right, I need to reflect this. So I need to reflect, so that means everything is going to flip. So I was in the bottom left, top right, everything flips and goes the opposite. And then I have that 3 there, so I took care of the negative by saying, all right, I'm in these two corners. The 3 there, again, is going to stretch things away from that center point. So my graph is going to come here and then pulled away like that. Down here, pulled away like that. So everything gets pulled away, reflected. That is the graph of this function. So talk about domain. Domain and range are going to work hand in hand with my vertical and horizontal asymptote. So domain is going to be all real numbers except x cannot be -1. My range is going to be all real numbers except y is not going to be 3. So a lot of the approach here is all based on figure out where your center is. So I figured out where my center is and then adjust it, transform it, slide it, whatever you're doing. Figure out if we're reflecting, stretching, what's going on. So these are my graphs of rational functions. By the way, that point zeros, or that center point, that is not actually part of a graph. Just the part in the curves is my graphs. So that is graphing rational functions 2.